Meeting tomorrow morning?
Nope.
Just
It's just all guys again.
oh, last
Yeah, if any of you have daughters, push them into into the engineering fields or physics or, you know,
They
It-
asked me, I was like, they're just not here. I don't know what's happening.
all right. Any of you having issues with the course entry assignment?
I failed the first time.
Well,
we all failed the first time, or at least for me.
That's just forced.
I got the religious question wrong.
Did you have fanatical devotion to the Pope?
I actually did.
you know where that's from, right?
Yeah.
No, what is that from? What is it from?
Monty Python skit.
What is that? Is that a movie?
They're a comedy troupe from the Great Britain.
They did a bunch of movies, but this particular thing was one of the skits they did. It was,
The Flying
It was-
Circus.
I wasn't expecting this kind of inquisition, and then three people representing the Vatican would come in and says, no one expects the Spanish Inquisition.
Yeah.
Our chief weapons is fear and surprise. Our two chief weapons are fear and surprise, and fanatical devotion to the Pope. Our three among our many. All right, so. Oh, I'm in the wrong chapter there. There we go. We'll just start out alphabetically. Raphael.
Here.
Yes. What's an insulator?
An insulator.
Yep.
It's an object that when rubbed and passed on electrons, the electrons stay trapped in that area where they were respectively rubbed. The electrons don't move around very well, they kind of stay trapped.
Okay. And an ideal insulator?
No flow of electrons.
Yeah, absolutely none. At least with in real life, if I have an insulator, I can get it to conduct if I
If you really try.
really try. Hector. What's a conductor? Your mic is off.
Might be on purpose.
All right, Hector. What's a conductor?
Something that like conducts electricity.
See. Let me turn the volume up so that I can hear you better. Nope, I cannot turn volume up any more than it already is. Well, we'll have to do as best I can. So, what is it again?
I said, okay, I said something very vague. I said something that conducts electricity, but how about more like something that passes electrons through it?
Yeah. I think we'll throw in the vague word of easily.
Easily. Oh, okay. So,
And it, yeah.
oh, that makes sense.
All right. Jake, charge of an electron.
It's negative.
Keep going.
The charge of an electron.
Yeah.
It, it flows with, I believe
I'm looking for a number.
oh, the charge of an electron?
Yes.
Is it 8.85 times 10 to the negative 12th?
It is not.
Okay.
It's a number in our notebook, right?
Say it again.
Came up that number the other day. I don't know where it is.
Negative 1.6 times 10 to the negative 19 coulombs.
Yes, it is. Or you could have done the simple root is it's equal to negative E.
Negative E.
Charge of a proton. Well, Jake, charge of a proton.
Yeah.
Oh, you weren't listening to Chance at all, were you?
I was. I just gotta go through my notes.
Positive counterpart.
Step, yeah, okay. Charge of an electron. I don't got it, man. Sorry, Dr. Fox.
1.6 times 10 to the negative 19 coulomb.
Yes, it is. Positive 1.6. All right,
1.6.
I'm sort of going in an order here, so some of you are just getting really simple questions. Chance, what's the symbol for charge? Yeah, what letter do we generally use for charge?
Go to the church signs, not sign.
Q.
There we go. I guess I just swapped questions.
Individual charge is little q, and then like a whole line of charge is, or collective charge is big Q.
All right, we're on a roll now. The direction of let's see, Ramez. The direction of forces between charges.
For the charges, say.
Yes.
The force field,
Not looking at fields, just the force.
oh,
In essence, if they're opposite charges, if one's positive, one's negative, what's the direction of the force?
it's gonna be the negative. If it's positive and negative, right?
Yeah, if I have a positive and a negative,
So it's gonna be the left.
it'll be left for one of them, right for the other, but
Right.
what do we know about the forces between charges? Open it up.
They attract
When?
when they're opposite,
And,
they repel when they're the same
Yeah,
sign.
the same.
yes, that's what I was looking
Oh,
for.
okay. My bad.
Your mind reading skills a little off today, I see. Jacob. What is the symbol for permittivity?
The symbol?
The symbol. What letter do we use?
I looked at my notes.
Now, I'm hoping we get to the point where you don't have to look at notes at all for any of this. Because,
Oh, it's, is it Sigma?
no.
No, Sigma's another thing.
Sigma was surface charge
I
density.
tried to look it up. Epsilon.
Yes.
Epsilon, sub naught.
If it's just permittivity, it's epsilon.
Okay.
If it's permittivity of free space, it's sub-zero.
Okay,
Or sub-naught.
got it.
It has been spoken before, who gets the lucky question here? PJ, what is the SI unit for charge? Yeah, there we go.
Sorry, Dr. Fox.
Yes?
What's the definition of permittivity?
Permittivity is a measure of how a material usually reacts to an electric field.
In terms of how well it conducts or
It,
insulates?
if I've got not in terms of conduction, in terms of, generally you're talking about things that don't conduct, insulators. And it's an indication of how polarized the molecules in an insulator become when exposed to an electric field.
Thank you.
William, what's Coulomb's law? Did someone do it without notes?
K Q sub 1 times Q sub 2
What is it called?
R squared.
Yeah, Coulomb's law. Yes. I know, Hector, how well can you hear us?
I can hear you okay, but I can barely hear the class.
All right. So don't forget to yell for Hector. We haven't really discussed this, but I'm gonna throw it out anyway. Pam, what's an electric dipole?
Give me the question we haven't discussed. Do you have notes on that?
Well, it's like later on.
I don't
An
know.
electric dipole.
Yeah, do you know what an electric dipole is, Hector?
It was only the number.
I think I know what a dipole is.
Okay, what's a dipole?
Is a dipole like when molecules.
Oh, do they have the same sign on both
One
sides?
at the top and two to the side or something like that?
Wait, say it again, Hector?
Battery.
Is it's a specific shape for a molecule, yes?
I would not characterize it as a shape of a molecule.
Is it, or is it that they have,
Bond.
Alright, let's see if we can connect it less chemistry.
we have positive, like it's polarized, so like a positive and negative on each side?
Yeah.
Okay.
So a dipole, basically di-2, you have a positive and a negative side, and they're basically, they're roughly the same distance apart no matter how the molecule orients. Or not necessarily a molecule, but however the object orients. All right. That runs us through, and then Micaiah is not here today with us, so. This is the flash stuff. So don't forget to look at the flash stuff. Next time if we do this, I would like to think that it would take 2 minutes to do the entire thing. It's the dream.
Was that the entire thing?
No, I did 8 of the 12.
Is the flash stuff on the blackboard?
Yes, it's the very first entry for each chapter.
Yeah, gotcha.
And it's set up so that if you print it out double-sided, the answer should be behind basically the question.
Okay.
So we do need Nimrod, coulombs, and electron.
These are things that are good to know cold. It's not the stuff that, 30 years from now, I'm gonna ask you what it is like I am for kinetic energy formula. But it's stuff that you should be able to fit into short-term memory. And this stems from a couple of years ago. I had a class that most of them didn't seem to realize that Coulomb was the unit of charge. And I just thought, we've been dealing with that since the very first day. I could not think of a legitimate reason. So I instituted the stuff that you should really know. Cool.
So I do have a quick question.
Yeah.
What is the Newton meter squared over Coulomb squared? What is that?
That would be the unit of
Force?
if it was just force, it'd be newtons, but Newton meter squared over Coulomb squared is the unit for Coulomb's constant.
Okay.
The 9 times 10 to the 9
Okay,
in SI units.
gotcha.
And so the unit for permittivity is just the reciprocal of that.
It's a flip.
Any other questions? William?
On the master step 23, there was a question, this second question, I think, where it was asking about an insulated rod. It's attached to 2 spheres that are hanging.
Right.
When you say an insulated rod, I don't know if you mean like the electrons won't move onto it, or that they won't move through it easily.
It won't move through it. If it had been a conducting rod, if I charge up a conducting rod, then those charges are basically gonna run into me. And in essence, I'm gonna ground it, and so that rod is neutral.
Okay.
So I made it an insulated rod so that whatever charge I put on it is gonna stay on it unless I do direct contact for transfer. Other questions? All right, I'm gonna run through a problem that it'd be really great to think that I could just give you the problem and all of you could do it like that, but based upon previous classes, I'm going to assume it'd be nice for me to go through it one more time. So I'm going to start out with 3 charges. Let's make this a 2 microcoulomb charge, a -4 microcoulomb charge, and a 6 microcoulomb charge. And I want to know, so I'm going to label this as charge 2, 4, and 6.
Is that 6 or -6?
That's a 6.
Okay.
what is the force acting on the 6 microcoulomb charge? Oh, I need to give distances. We'll make this 3 centimeters. Two centimeters and 1 centimeter. It does eventually stop.
Thing sure does love the beat.
And that's 3, we'll make that 3 centimeters. All right, so if we just treat this as a step-by-step. Apparently that's not what I need. Somebody changed my background. You get a long press to got it. Got it, thank you. All right, so conceptually, what do we know about the forces acting on the 6 microcoulomb charge?
The total force on the 6 microcoulomb charge is the addition of the force of the how does it go from 2 onto 6 and then from -4 onto 6? So it's both of those. You do those two separately.
All right, so we have the force on the 6 is equal to the force on the 6 from the 2 plus the force on the 6 from the 4. That sort of
Yes,
the quick and dirty summary of what you just said.
It's gonna go, down and right for the direction of,
Oh, in the end? How do you get that?
well, cause that's they're opposites, so wouldn't it pull it down, but since.
All right, so this one is gonna be pulled down because they're opposites.
Yeah.
This absolutely lovely shade of pale.
And then it's gonna be repelled from the same charge, so wouldn't that move it to the right a little bit?
Oh, it's gonna be repelled by that charge? Which is gonna be bigger, the repelling force or the attracting force?
the attracting force.
Why?
Because
It's bigger.
Coulombs.
Okay,
and
and
also the distance is smaller.
yes, both of those are taken into account. So this one's gonna be smaller, this one's gonna be larger, so the sum is going to be somewhere down and to the right as Jansen speculated. If we end up with something different, then we know we've made a mistake somewhere, because the reasoning is sound so far.
Do we have to start by figuring out the hypotenuse of the triangles, which is the distance between each charge?
Yeah. It's already been stated what Coulomb's law is, that the force, just the magnitude of the force, of the electric force, is K Q1 Q2 over R squared. We know the Q's, we know K, R is the thing we don't know at the moment. So what is that?
2 squared plus 3 squared? Well,
Square root of
2
13.
Square root, of- yeah.
And then square root of 10 for the other.
My head isn't wanting to math right now, sorry.
Do recognize that those are in centimeters, so we'll have to do that conversion at some point. All right, so we have gotten partway there, so let's just take a look at the force on 6 from 2. I know that the magnitude is going to be, so, I guess 9 times 10 to the 9th. maybe that one will stick. 9 times 10 to the 9th Newton meter squared per Coulomb squared. Times, what is micro?
10 to the negative 6.
Yep.
So 2 times 10 to the negative 6 coulombs, and then 6 times 10 to the negative 6 coulombs, divided by r squared, which is gonna be 13 centimeters squared. What is 13 centimeters squared in meters squared? How many decimal places do I move it over?
2, to the right.
3.
Like 4.
Oh, it,
Hector, what,
3, right?
what'd you say?
you're saying 3.
I said it's 3 zeros. It's 3 zeros. Different.
Oh, you're giving me a number of zeros. All right, so we have 13 centimeters squared. Recognize that if we are converting from centimeters to meters, it is 2 places, but I got 2 different centimeters here. It's squared. I got centimeters times centimeters. 1, 2, 3, 4. So it's 0.0013.
Well, isn't it the square root
Square
of
root is
13?
This
0.001.
is r squared.
Oh, okay,
Yeah.
we're keeping it squared.
Oh, that's smart. That's, I like that.
So anyway, questions up to here?
So it was 4.
It was, yeah, you would move
So,
decimal point.
Dr. Fox, if you converted, just making sure like the math works, if you converted the centimeters to meters before and then squared it, you would get that.
Yes, you should. Now, based on what I've seen other students do, it's, you might be slightly off of that if you round off at some point in between. All right,
I do have one.
yes,
Where are, okay, never mind, that's the charges, okay.
yep,
I was gonna ask about the 2 other numbers, but it's just the charges times 10 to the negative 6.
yes,
Okay, sorry.
no problem. William?
Is that is that like a standard rule with unit squaring, is that you take however many decimal places you would move over and then you square that number?
You would multiply it times however many units you have. Since I have two different centimeters, I would multiply times 2. If it were centimeters cubed, I would do it, moved it 6 places.